Okay, morning everyone. Welcome to this session number 446. Today I have this problem. Um, it's the number 146 and is LRU cache. And design a data structure that follows the constraints of Luis recently used cache. In this case, this is an essential an algorithm that help us to keep the cache using different um, rules. For example, the first is that you can set the capacity of the cache. Yeah, for example, in this case is three. Means that where you have, for example, three elements in the cache and appear a new one, means that the element with the less value in the update is removed and the new is added with the maximum value related with the update. Yeah, for example, in this case, um, the capacity is three. We have we insert or put the first register with the key and the value. Okay. Now the next that is this key number two and value B. In this case, for example, where every time that I am performing one operation over the cache, the element increase the value related with the update. For example, in this case, the key 2 now is the most recently item. It isn't with this, yeah. Even I think that here, with the highest priority, yeah. An essential is this: if you perform the operation of get, you return the value, and this value is updated with the maximum or the highest priority. Yeah, it's the same when you put a new element, you put with the highest priority. Yeah, and in this case, we need to implement the class. In this case, the first is the constructor essential that receive the capacity. We have another method named get that using a key as a parameter return the value of the key if the key exists. Otherwise, return less one. And the put update the value of the key if the key exists. Otherwise, add the key value paid to the cache. If the number of keys exceed the capacity from the operation, evict the least recently used key. If the number of key exceeds the capacity from this operation, this it. Yeah, it remove the 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 last element. And the important point here is that the function get and put must each run in constant time, average time complexity. This is the real problem. Perform this operation in this time complexity. Now, for this, I started this problem, and I am trying to use the double linked list. Why? Because, for example, I have this problem here. One moment. Now, for example, this is the one input. Okay, we have the first. In this case, this represents the size of the cache. In this case, is two, only two elements. Okay, got it. Now this is done and it's done. Now the next that is put. Yeah. In this case, we need to add in the map because we need a map. Yeah, and in this case one, and the value is one. This is because where we need to perform this operation is with the map is constant time. Yeah. Okay. In this case, I save here, and I am using the double linked list because I need to update the reference of the every node. For example, in this case, okay, we are here, one and one. The first step is create the node, in this case node, with the value 1 and 1. Got it? Now, the next is save this value in the map with the key, and here the object. Yeah. Oh, this object. Okay. 1 and 1 is an object. Next to is take the current double linked list or the list, and the last, no, the front of the list, in this case the front, it's equal the new, or it's equal to the highest priority. Yeah. In this case, I need to connect this with the new node, and the new node connect with the previous front. Okay. And and we need to all the time we need to know how many elements I have. For example, in this case I have two. Okay, it's not necessary remove any element. No, it's only one. Sorry, it's not necessary add any element. Now, okay, this is done and this is done. And obviously the front now is this. Okay, 1 and 1. Now the next that is another put, and is 2 and 2. Okay, the first is create the node. Yeah, and 2 and 2. And next to I need to save this value here. The key is this, and the object is 2 and 2. What is the next? The next is take the front. In this case, the front of the list is 1 and 1, and update the reference. Next is this, and back is this, and now we need to the front right now is this, but in this moment, we're still with two elements, and the capacity is 2. Okay, what is the next? The next is continue with this is done. Now is get. In this case, we're having the get, and the get is the 1 is this. I return the value. Yeah, it is easily. It's only check the map, but I need to check where is no. I know I don't need a transversal the list. It's only enough get the node. In this case, is take this and move here. Okay, and now this is connected. In this way. We don't know in this moment what is the next, but I know that contain this reference. No, is this. This is next, and this is back. Now we need to say the back dot next it's equal back dot next. Yeah. In this case, for example, this is back dot next. It's equal to back dot next. Yeah, and it's connected with this case with another. Yeah, and now the front dot next it's equal to 1, and 1 to back, it's equal to the node, and this it's equal to null. Yeah. And with this initial, I can perform this operation in constant time, I think. I'm not sure. Yesterday I was thinking and trying to solve this problem, and this is the only solution that I have, or I have in this moment. Okay. Well, whatever. Now, okay, even I will start again. Okay. Now, okay, the first I need a linked list. Oh, I need the class node. Class node, and this is the constructor. In this case, I need the integer key, integer val. What else? Key val. I need a node.pref, node.next, and I think with that. And now this key it's equal key. This dot val it's equal val. This pref null. No, it's equal null. It's equal pref, and this next well next. Okay, and I have this now. The only thing is, how can I do this? Okay, I think that I can create here the node. In this case, the node is named it, I think. Here it's equal null, and I need the capacity equal no. Only declare and here. Okay. Now, I think that point is enough, and no. Now for the get, I need a map. Hash map integer that is the key, and the value it's a node equal hash map. Yeah, and in this point is map get or default, because it's possible that doesn't exist. Thing, and the default is less one. Oh, one. But previous to return this element, I need to update the the node. In this case, you know what? I think that this, and ask here if map contains key but negative, I can return less one. This point, I'm sure that exists this key. Now I need to get the nodes, node, and it's equal map.get key. In this case, obtain the node, and I need to say n dot back dot next it's equal n dot next. For example, if I have x a 0, this is the node, and I am saying the back dot next it's equal to current or the node dot next. Yeah. And now this should be updated to this. That is the next and the next dot back is equal n dot back. This dot next dot back it's equal this dot back here. Yeah, and this is now it's not connected anymore with this. Well, it's connected, but the idea is that replace with the front. In this case is head dot next it's equal n dot is front next prep. I am putting back okay. Next is equal to new, and the new dot back is equal to head. Now head is equal head next. Sorry. Okay, now needs updated. Okay, I think that this it's done. The only thing is that I'm not sure if I need to update these values in the map. I have this though as well. Now for the put, this is another interesting point. Okay, the first I need to create a node. Value null and null. Okay. For example, if my current list is 2, 3, 1, 7, and I need to put this, and in this case should be appear here. But if this exists, I need remove. Okay. Okay, before this, I think that I can create map.get or default, that in the case that doesn't exist, the default is this. And key. For example, if I am putting the new element, it's 9. In this case, doesn't appear. Return the new one. And now I need to no. I think that first I need to validate if exists. Map.contains key is the key. If it's not contained, I can create a node, and it is this key value. The next or the previous is the head, and the next is null because it's the new. And now is head next equal n head is equal a head dot next. I move to the front, and now it's mapped to put T and N. And I need a counter. Okay, I can reduce this counter in one every time that I add a new counter. Let's now here where it exists, I need to disconnect the current node. I need to disconnect this node, and now is node dot back equal node dot next dot back equal n dot back. Now it's disconnected, and now I need to put in the front head next equal net next equal null, back equal ahead of ahead, and ahead dot next equal this, and head is equal head dot next, and dot back. I'm wrong here. For example, if n is equal 1, this is n dot back um n dot back dot next, it's equal n dot next, n dot next dot back it's equal n dot back, n dot next is equal null, good, and n dot back it's equal ahead, okay, ahead dot next it's equal n, and ahead it's equal ahead dot next is moved to the next. Okay, that I think that this point is done, is updated the reference. Now now the counter keep with the same values, because sys means that I don't need to add anyone. In this case, if counter it's minor than 0, it's minor than 0 means that I need remove one last element the list. Okay, now the last. Okay, in this case, for avoid to transversal many times the queue, I need two pointers, the head and the back, or is ahead and tail, is tail. check because my English is not very well. Uh-huh. Yeah, tail or back or something like that. And okay, this case, what happened is tail equal tail dot next tail dot back equal null. Ah, but previously to this, I need to remove this element from uh, the map. And next to is remove it. Okay. And okay. Case. Uh, uh, but here, I think that the last thing that I need to do is the handle the tail, beginning both tail it's equal null to. Okay, here is not move the tail. Here it's move where it doesn't exist. Where it's not contained. Here I need to validate if tail is null. Mm, 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 mm. What is the average of this? Ah, okay. Here is here, but how? Okay, where doesn't exist is possible if if tail is equal null, tail is equal n. Okay, but it's the same with the head null. Okay, where it doesn't exist, it's possible that both are null. In this case, for example, head equal null, that head is n. In the case that tail equal null, tail is mm, here I think that both are the same. In this case, is only this. Mm, uh, where is null? Set these values and I save in. No, because here. Wait, null, sorry. Null. Happen this. The prep is equal tail, that is null, and the next is equal null. Head is equal this, tail is equal this, and I save a value. Second time that I add a new element, for example, of this, now the new one is this. The tree is not contained, the head is null, no. The tail is null, okay, please have this. Tail is equal null, yeah, okay, tail is equal n, no, equal a head, head of next equal, you know, the value, the back is head, and the next is null, tail it's equal, my gosh, this is the new, means that head dot next it's equal n dot back is not necessary because I am doing this. Now it's a head, it's equal a head dot next. Save the value. And here is counter less. This is the same. Okay, in this case, all the cases counter less. But it's before the this. Here, here, Next, b dot back. What is b? Dot next and back. Well, this is n, right? Ah, yes, sir. This is back. I am returning and ah, one val n. Why? Ah, okay, because I removed the n. It's equal key value. In this case, doesn't exist. I see null. Now head dot next equal n. Got it? Head. No. Here is n dot back equal head. Head dot next is n. Yeah, because head n dot next don't have anything. Counter. Why? Counter is capacity. I will update it to counter. Here is not necessary. Counter hail. No, yeah. Okay, I will check the answer. This is with the volunteer list. The code. Mm. Oh, okay. I had the same idea. Use the reference here. It's the same. Yeah, the only problem was this, I think. Okay, I think that my failure is because I don't handle correctly in special with this, with the initial state. I think that I can fix it as well. I think that it's enough for this transmission. Thanks for following this streaming, and I hope see you in the next. Bye bye.